Good afternoon, ladies and gentlemen. If you'll please take your seats so that we can proceed with the afternoon keynote. I trust all of you had a great lunch and are ready to come back and go through the afternoon. Well, good afternoon. It is my pleasure to introduce our afternoon keynote speaker. We're very pleased to say that we have Amazon in the house. Andrew R. Jassy has been Senior Vice President of Web Services of Amazon, Inc., Amazon.com, Inc., since April 2006. Mr. Jassy served as Vice President of Web Services at Amazon.com, Inc. from January 2005 to April 2006. He served as Vice President of Associates and Web Services of Amazon from September 2003 to January 2005, and served as its Vice President and Technical Assistant from November 2002 to September 2003. Prior to Amazon, he was founder of Marketing Consulting Company in 1997 and served as its manager. He served as a director of Coupa Software, Inc. Mr. Jassy is a graduate from Harvard College and holds a master's in business administration from Harvard Business School. Please welcome Andy Jassy to the stage. Thank you.
Thank you, guys, and thank you for the very nice and gracious introduction. I'm Andy Jassy. I'm Senior Vice President of two areas of Amazon, our Amazon Web Services business, which is our cloud computing business, as well as the technology infrastructure part of Amazon. I've been at the company for 14 years. I've worked on every business that Amazon has pursued. And I wrote the business plan for our AWS, or Amazon Web Services business. So I've been working on this business for 8 years. I wrote the business plan 8 years ago, and we launched the first service, S3, in this business in 2006. So it's been really neat to watch how this business has evolved and be a part of it. I am really pleased to be here today at the annual Technology Summit for NASA. Amazon is a company that really prides itself on being innovators and listening to customers and inventing on their behalf. And we've only been at it for about 16 years as a company. And when I think about being here with NASA and the unbelievable amount of innovation and discovery and the ability to show the rest of the world what's really out there beyond just what we can see, it blows me away what NASA's done, and it's really an honor to be with you guys here today. I thought I would start by giving you, at a high level, how we think about our business at Amazon at the highest levels of the company. And we think about Amazon now as having three macro businesses. The first is a consumer products business, which sells retail products and services to consumers. It's a business that's been around for 16 years. It's several tens of billions of dollars at this point. Most folks know about this business. Our second business is a seller business. And this allows third-party sellers to sell their products on Amazon.com. And it also provides technology for third-party sellers to use on their own websites to fuel their e-commerce experience. And this business has been around for about 10 years and is also a multi-billion-dollar business for Amazon. And the third business is our developer business, or our IT infrastructure business, which is AWS, or Amazon Web Services, which allows businesses and developers to build their technology applications on top of our infrastructure platform. We used to get asked this question quite a bit when we started the business about 5.5 years ago. And the rude way it was asked was, what's a bookseller doing offering compute and storage and database functionality? What do you guys know about that? And that, of course, seemed like a very odd thing to a lot of people that didn't understand the context of where Amazon came from. So I thought I'd give you a little bit of an idea about what was going on around that time that didn't make it seem as strange as it might have appeared initially. So the first thing was, we were actually working on this business, this AWS cloud computing business, for about 10 years without really realizing it. And that's because to move as quickly as we were on www.amazon.com, which is, at the end of the day, just a massive web-scale application, we had to get really good building infrastructure services deep in the stack, things like compute and storage and database functionality. And we had to get really good at running really cost-effective, really reliable, really scalable data centers because our retail business is a really small margin business. So it turns out we had a real competency in running infrastructure services and scalable data centers. The second thing that was going on was that we started to pursue this seller business that I mentioned earlier, and we called that business merchant.com. And it allowed third-party merchants, folks like Target, to use all of Amazon's technology to fuel Target.com. And when we went to deliver that solution to merchants, it was actually a lot more painful and a lot more time-consuming than we assumed it would have been. And that's because as we built the business so quickly, we had ended up with a bunch of pieces of our platform entangled that we really wished weren't. And so we became big believers through the experience of delivering this solution of merchant.com in service-oriented architecture and loosely coupled pieces. And from that point forward at Amazon, we expected to build all our services in this loosely coupled fashion, and internally, we expected to consume all of our services in an SOA fashion. So that was the second thing going on. The third thing going on was that we were expanding Amazon really quickly in the years 2002 and 2003. And we were adding software development engineers at a really rapid clip. And yet it was still taking us a really long time to get product development projects done. And at the time, I was working for Jeff Bezos as his, we call it his executive shadow, but it really was a chief of staff role. And he asked me if I would go talk to a number of product development leaders and figure out what was going on. And when I talked to folks, they said, look, I know you guys think end-to-end these projects should take 2 to 3 months, but it's taking us 2 to 3 months just on the storage solution, or just on the hosting solution, or just on the database solution. And Jim's doing the same thing on the 3rd floor, and Sally's doing the same thing on the 6th floor, and none of us are adding any value beyond our own project. None of what we're building scales beyond our own project, and it's frustrating. And we listened to that feedback and thought, aha, there's a real thirst internally for reliable, scalable, cost-effective infrastructure services. And even if we had never built the business, AWS, to offer to third parties, we would have built all these services for Amazon, the retailer, to move much more quickly. And then the fourth thing that was going on all around this 1999 to 2003 period is that we had a part of our retail business called the Associates business. And it's a program that allows third-party websites to merchandise Amazon products, and if it leads to a sale, they earn about a 5% commission. And we have about 1 million third-party websites as part of this program. And that team was experimenting with all kinds of different ways they could be more ubiquitous across those associate sites. And one of the tests they tried was they took all the product data, the product descriptions, the customer reviews, the pricing, the in-stock availability, and they put it in an API. And the theory was if they decoupled the data from the presentation, associates would do more clever things with that data than we would have thought of just ourselves, and we would never get around to half the things that associates found. And if that happened, it would lead to better conversion on their websites, and it would lead to more placements, which would help the associates business. And what we found was that like sites that used the API versus those that did not converted about 30% better. But what was really startling to us was that thousands of developers flocked to this API without any promotion from us and started using it in all kinds of ways that we never envisioned or imagined we would ever get to ourselves. And so all of these things came together around mid-2003. And we took a step back at Amazon and we said, if you believe developers and businesses will build applications from scratch using these web services, if the right selection of web services existed, and we believe they would if the selection existed, if you believe that, then the operating system becomes the internet. And if you believe there's going to be an internet operating system, then we ask ourselves, what are the key components of that internet operating system? Which pieces have already been built? And which pieces, given what Amazon's good at, could we meaningfully contribute to? And when we looked at that in mid-2003, we realized that none of the key components of the internet operating system had been built yet. And when we thought about what Amazon is good at, and Amazon has always been a technology company at its heart, one that applied the technology to the retail business first, but always a technology company, we realized we could contribute most of the key pieces of the internet operating system. And with that, we decided to pursue this much broader mission, which is our mission in AWS today, which is to enable businesses and developers to use web services, what people call the cloud now, to build sophisticated and scalable applications. Then we had to figure out what services to build. And today that seems much more blindingly obvious than it was back then. But this vision of wanting to be able to allow the maximum number of developers and companies to build their applications on top of our infrastructure, that's what drove what pieces we've built. And we think of these as building blocks. So for compute, we have the Elastic Compute Cloud, or Amazon EC2. We have 2 storage services. We have an object store and Amazon Simple Storage Service, or Amazon S3, and a persistent block store in Amazon Elastic Block Store, or Amazon EBS. We have 2 database services. We have a relational database service that we call Amazon Relational Database Service, and we offer that both in a MySQL flavor and an Oracle flavor. And then we also have a massively scalable key value object store that we call Amazon SimpleDB. And then we have a content distribution network that actually has the most amount of customers of any content distribution network in the world, called Amazon CloudFront. We have a couple messaging services. We have a queue service called Amazon Simple Queue Service, a notification service called Amazon Simple Notification Service. We have an email service called Amazon Simple Email Service. We have probably one of the most popular big data services out there right now called Elastic MapReduce, which is really a Hadoop implementation on top of EC2. And more enterprises and agencies are using this service to do broad analytics. And then we have a service called Mechanical Turk, which is really an interesting cutting-edge service that is effectively giving companies access to a very large, high-quality, inexpensive global network on demand of workers to do all kinds of tasks that computers aren't great at doing themselves. And then we have a number of features that we've built on top. Many of these are intended to pursue and to enable enterprises to use our cloud in the way that they want to move more of their workloads over. So we have a consolidated billing capability. We have an identity and access management capability that allows enterprises to control the credentials and the access of various users in their organization. We've built a monitoring service called Amazon CloudWatch. We've built an ability to auto-scale resources where you can set triggers as a customer on when you want to scale up resources or scale down resources, and we'll automatically take action for you. We've built a number of networking capabilities. We have a DNS service that we call Route 53, and we have a load balancing service that we call Elastic Load Balancing, as well as a virtual private cloud service I'll talk about in a few minutes. And then, of course, we have a number of accesses, at a higher level. We have a Java container that we call Elastic Beanstalk. We have templates that make it easy for you to create templates and replicate them in repeated jobs called Amazon CloudFormation. And we, of course, have a GUI that allows you to deal with our various resources with a website GUI. And when we started AWS, we had a pretty massive debate about at what level we should build these services. And there were some people internally that felt we should build them with lots of features right from the get-go. And one of the principles and tenets that we operated under was that we wanted to provide people highly flexible, non-paternal, low-level building blocks that allow businesses and developers to stitch these services together however they see fit. And one of the reasons we did that was that we wanted to enable the maximum number of use cases that companies can use these services for however they wish. And so that's why you see, if you look at the diversity of use cases, you see everything from website and application hosting to SaaS hosting to content delivery and media distribution to all kinds of high performance and batch and analytics computing to archive and disaster recovery and backup to, of course, development and test. Now, big data, many of you people, probably, the group in this room have probably heard the term big data. And it seems to me, in the same way that cloud was used for everything a couple of years ago and had a pretty big hype cycle around it for most companies, big data seems to be the new big cloud in terms of hype. Everyone's talking about big data. And when you ask people what big data is, it's often really unclear what they mean by big data, and often it's difficult for a lot of these companies to explain what big data really means in terms of services. And the way we think about it is that the cloud is changing the viability and the cost of being able to collect, store, analyze, and share data. It's a very different world in terms of what you can do today. You can use AWS building blocks today to handle all kinds of these big explosive data set capabilities. You can use our storage services like S3 to store all this data, to collect and store it. You can use our compute service, EC2, to do any kind of processing you want. You can use our Elastic MapReduce service to do really large-scale analytics and batch processing of these data sets. You can do that today with our services. And one of the things that we're seeing with big data and the cloud that enables it when we talk to customers is, for years and years and years, CFOs and companies would say to CIOs or development teams, they'd say, look, you need to know what questions you want to answer from this data, and we will provision enough infrastructure to allow you to answer those questions. And what the cloud allows is you don't have to make those choices anymore. You don't have to know exactly which questions you want to answer. The cloud allows you to find all the diamonds in the rough in that data, where a lot of the most valuable insights often are, and that either aren't happening or took dozens of years to actually find. So it's a big game changer, and you can use that right now with the various building blocks that AWS has. I'm going backwards here. Here we go. The business, as I mentioned earlier, is growing very dramatically. We have hundreds of thousands of customers at this point in over 190 countries. And our customers really range in size from some of the largest, most successful startups like the Zyngas and the Playfishes and the Twitters of the world to large enterprises like Eli Lilly and Adobe and Netflix and Newsweek and Intercontinental Hotels and Fox and Sony, to government agencies like NASA, and there are over 100 agencies at this point using our services. The ecosystem of ISVs and systems integrators are continuing to grow really, really quickly as well. And that's because we have a tenet in AWS, which is that we don't want to force our customers to pick an operating system or a programming language or an application platform. We want to support whatever our customers want. And so this ecosystem is growing in significant part from customer input on what customers want us to be able to support on top of our infrastructure. And so this ranges in ISVs from SAP and Oracle and IBM and Citrix and Dassault to systems integrators that range from some of the largest, like Accenture and Deloitte, to literally thousands of systems integrators. And what's interesting thus far in the cloud is that many of the smaller and more regional systems integrators are the ones that are actually doing most of the cloud work, as they're moving more quickly than some of the bigger guys. I thought, in addition to having hundreds of thousands of customers in over 190 countries, I thought I would give you a couple other data points that just give you an idea of our size and scope at this point. So this is our storage service, Amazon S3. And you can see that in the first year that we launched the service, which was 2006, there were roughly 3 billion objects stored in S3. By Q2 of this year, we had over 449 billion objects in S3. NASA has 200 million objects stored in S3. And to give you an idea of the scope of the service, at its peak request rate, it's handling over 290,000 requests per second, which is pretty significant scope. Here's another data point which is kind of interesting to give you an idea of how fast we're adding infrastructure. Every single day now, AWS is adding enough server capacity to have powered all of Amazon when it was a $3 billion global business. So think about that. Every single day, we're adding enough new servers to fuel a $3 billion global Amazon business. So we're adding quite a few servers and data centers every day and very quickly. I don't suggest you try to read this slide. It's a little bit of an eye test. But what it's intended to communicate is that the pace of innovation inside of AWS is really intense and really fast. In 2009, we launched over 60 new features, significant features and services in the platform. In 2010, that number was 150. In 2011, we expect that number to be higher than last year. It's continuing to accelerate, which is great for federal agencies to have a large, very focused organization like AWS iterating really quickly to provide additional capabilities. We also have a geographic footprint in various places throughout the world. So we have 2 US locations on the East Coast of the United States and on the West Coast of the United States. We have a location in Ireland in the EU. We have a location in Japan, in Tokyo, and then one in Singapore. So our geographic footprint is expanding, and you should expect that to continue. And then I thought I would say a few words about a topic that's super important to all of our customers. And we often get asked by customers, they get the value proposition of the cloud, but understandably want to know how they can take some comfort in the fact that their data and their services will be secure inside the cloud and inside AWS. And what we tell people is that we use all the same tactics and strategies for security that enterprise data centers have been using for the last 30 years. We have very significant and tight access control physically to our data centers. We do network inspection to make sure that none of the packets are being intercepted or intruded. We are very careful to wipe all of our servers clean when customers have been using them and then decide to abdicate them. But customers will say, well, that's all well and good. I'm glad to hear that. But I'd like some third-party certification that that's actually happening. And so that's why we've pursued a number of the certifications that customers have told us matter to them. And they range from FISMA to ISO 27001 to SAS 70 Type 2 to PCI certification. We were the first cloud provider to be certified for people to run PCI-compliant applications in it. We've also added 2 other capabilities that we think are really important to security. One is identity and access management, and this allows companies to effectively have a central control or a senior controller of accounts, and then to create users underneath those accounts that you can control. They have their own security credentials, but you can control what type of privileges and access they have to each individual piece of data that you want to provide access to them for. That's very helpful, that level of granular security and access control. And then something that we call VPC that I mentioned earlier called Virtual Private Cloud. And the way to think about VPC is it effectively allows you to cordon off a part of the AWS network, launch your AWS resources into that sectioned off part of our network. It can only be accessed through IP addresses that you bring to bear. If you want to allow broader access to the internet, you can set that up too through subnets. And you can hook up a VPN from your own data center to VPC so that VPC really effectively becomes another data center in your network. It has the type of network topology controls that let you set up the network topology however you want, and that's like the way you set it up now. It lets you run all of your same monitoring and security management tools that you use now. And so we're finding this has been very, very popular, not just in the enterprise space, but also for the federal agencies using our services. So I mentioned earlier there's been quite a bit of noise about the cloud. And part of what we saw early on with the cloud, when we first launched the services, people said, well, nobody's going to ever use those. They're toys. And then when people started using them, people said, well, I don't know if anybody's going to use them for anything real. And then when people started using them for real things, people said, well, I don't know if people will use those to run their businesses. And then when people started using them to run their businesses, people said, well, startups will only be the ones that ever use them. And now as enterprises start using the cloud for, and the government starts using the cloud for significant purposes, everyone has jumped on the cloud. And people have attached the word cloud to almost every offering. Even if there's not much of a difference in the offering from the last 10 years, people want to be current. And so it's very confusing for people to understand what is the cloud and what isn't the cloud. And I'm not going to take a stand on what is or isn't the cloud. But I thought what I would do instead is give you our opinion about what are the benefits for why people are moving to the cloud. What are the things that matter to people, and how the old world of technology is changing to this newer world of technology that leverages those benefits of the cloud. So in the old world, you had to spend a lot of CapEx if you were building applications. You had to lay out the money for those data centers. You had to lay out the money for those servers or for your network, and it was all capital. Capital is often scarce. In the new world, you get to turn that capital expense into a low variable expense. That's a big difference, not having to lay out that capital up front. In the old world, what you found was that, I would say the old guard technology companies typically charged as much as they could charge. And that is a perfectly reasonable business strategy, to charge as much as a customer will bear to pay. But it was fixed price and it was expensive. And they were all separate negotiations on how much you could get for that piece of business. In the new world, you only pay for what you use. You don't have to pay a big fixed amount up front. We're not actually trying to, get every last cent from you. We're very transparent and open about what our prices are. You only pay for what you use, a low variable price. Very different model. In the old world, you had to guess on what your capacity needs were going to be. And anybody who's had to do this before will recognize a chart that looks something like this. It's not easy to predict what your capacity requirements are going to be. And so if you look at that dotted red line there, that represents a typical demand curve that somebody may project. And you have to make that decision up front usually. That green line is an example of what often happens, which is actual demand. On the left side of that chart or graph, you can see that you're way over provisioned and you're sitting on all this excess money that you didn't have to spend. On the right side, you can see that something's happened in the demand curve that's made your application more attractive. And you have way less capacity than you need. And companies are faced with the hard decision of either providing a really bad customer experience because you can't handle that level of traffic, or more often what happens is companies scramble around, find some kind of provider, a colo provider, often have to provision for the peak, even if they're not going to stay at that peak for very long, and be stuck with a lot of excess waste. In the new world, you don't have to guess. You can seamlessly scale up as you have demand, and you can seamlessly shed those resources when you no longer are living at that peak. So here's an example. I'll show you a video application that's become very, very broadly popular. And you can see that orange line represents, they were kicking along at a few hundred EC2 instances for several weeks. And they launched a Facebook application, and they started to get some increased demand. And then they figured out how to optimize that Facebook application, and it exploded. They went from needing a few hundred EC2 instances to nearly 5,000 instances in 48 hours. Now think about what you would do in the old world. You would either not be able to meet that demand and provide a bad customer experience, or you'd run around and pay through the nose and sit on a bunch of capacity you didn't need and commit to it for 2 or 3 years and overpay. And so when you see actually that they hit a peak and then actually came down to a more normalized level, they didn't have to keep living and paying for that peak. They got to move down seamlessly, and that all happened without anybody being involved, just them using our services. It's really a game changer when you think about infrastructure. In the old world, if you need a new server to run an experiment, to put something in tag, to try something new, it would take anywhere between 2 or 3 months. When we talk to engineers inside various enterprises, we got estimates between 6 weeks and 20 weeks to get a server, if they were allowed to get a server in general. That's maddening for engineers and for development teams. And what it does is it really deters people from trying experiments. Because why bother? It's going to take so long to get the server if you ever get it in general. And it's part of why so many great ideas never see the light of the day. They get backed up behind other projects. Oftentimes it's the wrong call, that's the prioritization, and people just stop trying experiments. And what you'll find if you talk to anybody that does a lot of innovation is that they'll tell you that there are 2 things that are most important in trying to do a lot of innovating. The first is to be able to have lots of attempts and be able to run lots of experiments. And the second thing is, if those experiments don't work, and if you're really pushing the envelope, a lot of them should not work. That if they don't work, you don't have to live with the collateral damage of failed experiments. And so in the old world, that's just not viable. In the new world, you can spin up hundreds, even thousands of servers in minutes. And that means that if you not only get to try a lot more experiments than you ever had done before, which increases the new projects and new ideas and new findings and things that push your business forward, but also if your experiments fail, you either just give the resource back to us and you don't live with the long-term cost, or you use them for new experiments. Again, very, very different model. In the old world, you have to live with what we call the undifferentiated heavy lifting of infrastructure. We call that muck. And this takes the form of things like getting data centers and doing the contract negotiations and buying the servers, installing the servers, migrating the servers, managing the heterogeneous hardware over time, setting up the network, managing the network, operating the network. It's not brain surgery. It's not impossible to do, but to do it well takes a lot of time. And when we were starting AWS, we asked a lot of internal development teams, we said, how much of your time is spent on managing the infrastructure, and how much of your time is spent on differentiating pieces of whatever feature you're building? And we were stunned that people said 70% of their time was spent managing the infrastructure. And then we started asking engineers and leaders outside of Amazon, and we saw that that ratio was more like 80-20. And that really surprised us quite a bit. And so in the new world, we're trying to flip that equation on its head. We want customers, companies, to be able to spend most of their time, most of their development cycles on the pieces that really differentiate what they're doing versus the undifferentiated heavy lifting of infrastructure. There are a tiny, less than, I think, 1/10 of 1% of the companies in the world that truly differentiate their product or offering based on the infrastructure. If you can take those scarce resources that are SDEs, software development engineers, and have them spend time on the things that differentiate your product and offering and your mission, it's a huge advantage. So everybody has heard a little bit about the private cloud. We hear about that too. And it's often very hard to know what the private cloud is versus what it's not. And there's a raging debate about whether or not the private cloud is a cloud or isn't a cloud. And again, I won't take a side on that issue. But I thought what I would look at is I would look at what the key benefits of the cloud are and then just evaluate whether the private cloud meets those. And again, is the private cloud an old world offering or a new world offering? And so if you look at the ability to turn capital expense into variable expense, that's not true in the private cloud. You still own all the capital. You own the data centers. You own the servers. Are you paying a low variable expense? No. Usually you're paying a big upfront fixed expense for those private installations. Do you only pay for what you use? No, because you have to pay that non-variable big fixed upfront fee. Can you scale seamlessly up and shed resources at a moment's notice if you need to? Not at the company level, maybe at a department level, but at the company level, because it's your private instantiation of those data center and server resources, you have whatever you buy there. Can you spin up hundreds or even thousands of servers in minutes? I give this an orange check because in well-provisioned private clouds, you can spin up servers quickly. Spinning up hundreds or thousands of servers in minutes, not usually so often. And you get to focus your scarce resources on things that differentiate your product versus managing the infrastructure, not so much in the private cloud. You still own it and have to operate it. And so when we look at whether we think this is really a new world offering or an old world offering, we see it much more as an old world offering. There will be some companies that and organizations that have to operate in this environment for regulatory reasons. And it may seem like something of an in-between step for some organizations to get into the cloud. But these are the reasons why we don't think in even the short and medium term that private cloud is going to be the long-term solution. So today we have a pretty exciting announcement to make. I'm really excited to be up here telling you about it first. This is the first anyone hears of it. Today we're announcing a new region for AWS that's called AWS GovCloud. And one of the reasons that we're announcing it here is because a lot of the impetus for it, a lot of the guidance for it, a lot of the input for it was very much influenced by NASA JPL, who really put it on our radar screen earlier than anybody else. NASA JPL has been using our services for a couple of years and really are pioneers. And they not only pushed us to do this much more quickly, but gave us really great input into how we should build it. And so we were happy to announce it at this conference today. And what it is it's a new region that effectively has all of the services that companies have come to know and love in AWS, like EC2 and S3 and EBS and VPC and Identity and Access Management and our CloudWatch service. But it offers those in a region that allows you to be ITAR compliant and that has FISMIT moderate compliant controls and allows you to have an environment with FIPS endpoints that you can connect to. And it lets you run in a region, which is very important to a lot of federal agencies, that is only physically or logically accessed by US persons. And I mentioned VPC earlier. AWS GovCloud, all customers will run in VPC in AWS GovCloud. It allows you, as I mentioned earlier, to treat AWS and VPC here in an ITAR compliant way as just another data center in your network. But it also has a couple other capabilities that we think a lot of government agencies will find useful and helpful. One is we have a feature called dedicated instances, which is optional, which allows agencies that want to be the only entity running on boxes to be so. They can choose to designate that. And we also have a feature called Direct Connect. And what Direct Connect does is it allows you effectively to peer from your own data center to AWS, directly to our data centers through a shared co-location spot that we both connect into. We have quite a significant ecosystem that has been growing really every month and very quickly over the last 18 months. And it ranges from ISVs like Esri and Appian and SafeNet and Adobe to systems integrators like Apttus and SAIC. And that list of systems integrators is growing very quickly, as are the ISVs. We also have over 100 federal agencies at this point that are using AWS. Of course, NASA has been using for a while, the Recovery and Transparency Board, the Treasury, the Department of Agriculture. Those are just a few, but over 100 at this point are using AWS. I thought I would give an example, a few use case examples, and I'll again use NASA JPL as an example. As I mentioned earlier, I wrote the business plan for AWS, and I've been involved in the business from the very start. And I've been around all of the companies, large and small, that have been using AWS from the get-go and as it's evolved. And I'll tell you that JPL is one of the most forward-thinking, innovative, thoughtful customers that we have in any sector, period. It's really a pleasure to work with them, and they gave us quite a bit of input, not just in GovCloud, but also in our offering that's outside of GovCloud, in our normal regions. We continue to get really great input, and so I thought I would give some use cases from JPL. So these are all missions that either are using AWS or intend to use AWS, and they range from the Mars exploration rovers to the Mars Science Lab, to the Deep Space Network, to CARVE, to the Lunar Mapper mission project, to the Athlete robot, to the Orbiting Carbon Observatory. And I'll give an example here where the Mars exploration rover, we're using AWS starting really in November 2010, became the first NASA mission to use a public cloud in a real mission, and taking all the large number of photographs coming from that Mars Explorer, that Ranger rover, taking those images, bringing them down to our storage service, storing them, doing processing on them, and then using that to help instruct what it wanted the rover to do moving forward. Very innovative use case, and something that JPL told us they were able to do much more cost effectively and about 5 times faster than they could have done in-house. Here's another example that's more recent. So the new Mars rover, Curiosity, which is supposed to land, I believe, in August 2012. Before it takes off, JPL wanted to run a bunch of tests to make sure that the telemetry worked and the equipment worked, and there was a lot of learning before it was gone. And so it ran a fast motion field test, an image processing, and it used image stitching to stitch together all these images to test and provide a panoramic view of whatever pictures that were being taken. It used something called stereo correlation to effectively take multiple images, multiple views of an image or an object, and then provide depth perception so you could tell how far away a particular object was, and then larger image tiling that allowed JPL to kind of zoom in or zoom out and get different views of that object. It spun up hundreds of cores in just a few weeks, did this testing, learned a bunch of things about the telemetry and equipment being used, and then spun them down and didn't have to pay for it anymore. And so we're very hopeful, like with the last Mars rover, that JPL will use AWS to process all of those images. But I think this is a great use case for lots of different missions to be able to use cloud computing in AWS to get going and to test or to try things or run experiments that otherwise would have gotten backed up and never done, or done at the very last minute or in a much more expensive way, and be able to do it much more easily on AWS. This is another example from the European Space Agency. And so the ESA has something called the Center for Earth Observation, which is a whole bunch of data that's collected by satellites that gives information on the planet. And it provides monitoring information. It provides, they use it for weather predicting, also for assistance with disaster recovery. And they store all of those images in our storage service, Amazon S3. And then it sends that data to scientists and organizations of all sorts all over the world. And at peak, you can see that tens of thousands of users using a fair bit of data are using this frequently. And again, using it for speed and agility, flexibility, and cost reasons. So I thought I would provide a few closing thoughts here. And as everybody moving forward thinks about how to move more of their workloads into the cloud, we get asked a lot, what should organizations think about when they're trying to decide who they should work with, who they should partner with in the cloud? And I would list probably 5 things to think about. The first is security. If you don't have a partner who you believe security comes number one, and if you're not comfortable with their security environment, you don't really have a partner. So that's always, we call that priority 0. It's really the first priority in everything we do. The second is experience. You know, I mentioned earlier that the reason that we started pursuing this business 8 years ago was that we thought we were pretty good at running infrastructure services and really reliable, scalable data centers, and we thought we could probably provide that service to third parties. Well, I can tell you 5.5 years later, after having these services out with hundreds of thousands of customers in over 190 countries, with every imaginable use case, and not needing to inform us when they're going to use us, they just can write to the API, we are much, much better at this today than we were 5.5 years ago. And, you know, the operational performance of our platform has really been quite good over the 5.5 years. It's one of the reasons that we've grown as quickly as we have. But we've also had some hiccups along the way. And the only way, though, that you can have those hiccups and really understand what's causing those things and how to guard against those things moving forward is to be able to have the number of services, the number of customers, the massive amount of scale that AWS has. We often talk about inside on the team that of all the things that we feel like are advantages for AWS at this point, arguably the biggest is our scale and the number of people using us allows us to learn so much every week and then be able to pass those back to our customers in the form of, in lots of forms, including operational performance. So we use an expression which I think is really apt here for the cloud, which is there's no compression algorithm for experience. And I think that's really true. You just can't learn the things that we're learning right now until you reach this type of scale. The third thing I think is really important in who you work with in the cloud is flexibility. We've heard repeatedly from customers that they don't want us to choose which operating system they use. They don't want us to tell them what programming language they have to use. They don't want us to tell them they can use all of our services or none of their services. They don't want us to tell us which application platforms they use. Customers want to make those choices for themselves, which seems perfectly reasonable to us. And so that's what we're offering. We allow customers to use any operating platform, any programming language, any application platform. They can use all our services, some of our services, one of our services, none of our services. We're not trying to lock people into our platform. We want to earn that business every single day in whatever set of pieces that people want to stitch together themselves. The fourth thing that I think is really important is listening to customers and iterating quickly. And so I would tell you that outside of our security and operational performance thus far, the thing that the team is most proud of at this point is the pace with which we're innovating and iterating. And if you look at our platform, the AWS platform today versus 5.5 years ago, it's hardly recognizable. It's night and day different in terms of the number of services and features we have. But I think we're at the very beginning of what our platform is going to look like 10 years from now. And so you want to be working with a partner that listens very carefully to what you tell them is important and then is able to iterate quickly. And that sounds a little bit like motherhood and apple pie. Every technology company will tell you that they listen to customers and they deliver fast. But if you look at the actual performance over the last 5 years of the pace of delivery of AWS versus most technology companies, it's pretty different. And the last thing I would point to is costs. And so I think costs matter to every company, every agency, every entity out there. And at different times, it may matter more or less to different entities, but almost always at some point, cost really matters. And we have, at this point, if you look at AWS, we have lowered our costs 14 different occasions in the last 4 years, largely in the absence of any competitive pressure to do so. And the reason is because of the way we approach our business. We think of everything at Amazon with starting with the customer and moving backwards in your strategy from there. And I've been involved in every business Amazon's been in over 14 years, and I can tell you that I've never met customers that want to pay more. And so if you have that perspective, then you're looking constantly to try to find ways to lower prices for your customers. I also think it's reflective of a belief that we have, which may be different from other players and IT companies in this space, which is that we believe that most of the computing is moving to the cloud. That's, we're at the beginning of a titanic shift. And if you believe that, which we do, then it follows for us that it's going to be a very high volume, relatively low margin business. It is really different to run a high volume, low margin business than it is to run a business that's used to getting 70, 80% gross margins. You think about your pricing differently. You think about your cost structure differently. You think about your need to invent differently. If you can take cost out of your own structure, whether you pocket those savings and take extra margin or give them back to customers in the form of lower prices, you think about that differently. Amazon, in every business we've pursued the last 15 years, has been in high volume, low margin businesses. We love those types of businesses. We're very comfortable with those types of businesses. It's in our DNA. Other large technology companies, it's very, very different from the way that they have operated on 70 to 80% gross margins the last 30 years. And I think it's part of why you see such a push to pursue the private cloud, because it really protects their existing business models, and they don't want it to move the way that AWS is trying to take it for customers. But I think in the fullness of time, and you're already seeing it start to happen, I think all companies in the technology space are going to realize that it's going to be a high volume, low margin business. And then at that point, it's going to be interesting to see if those other large IT companies are good at running high-volume, low-margin businesses, because you don't just flip a switch overnight and become great high-volume, low-margin operators. It's a huge logistics and operations game to run these high-volume, low-margin businesses. It'll be interesting to see how excited and comfortable others are in doing it. So I'll close with this slide, which this is a picture actually of our founder and CEO, Jeff Bezos, at a Belgian beer manufacturer. And in the middle there is an electricity generator. And it didn't really, about 150 years ago, most businesses generated their own electricity. And it didn't really make the beer taste any better, but it really was a necessary evil at that point. And then, of course, with the advent of the electricity grid, the economies were such that it didn't really make sense to generate your own electricity. And I think we're at the very beginning of a similar type of shift in computing, where in the fullness of time, I don't know if that's 10 years from now or 20 years from now, I think very few companies are going to have their own data centers. And those that do will have much smaller footprints than they currently have. And that's because the economies of the cloud are just too great to make it make sense to run your own data centers moving forward. So once again, I want to thank you guys for having me here. It really was an honor to be with you. And I look forward to working with many of you in the future. Thank you. Thank you.
Okay, at this point, we don't have time for any questions. So this is the end of our keynotes for this IT Summit. So the sessions start in about 30 minutes. Tomorrow morning at 8 o'clock, we start again, but it'll be just the track sessions. Okay, so this is break time. So for 30 minutes, we'll have a break and then start the sessions again.